Now question number 2. So let's read what we have to find, and then we'll go back and read the information. So part A is asking us to identify the treatments, experimental units, and response variables. So let's go back and read the information. Holly, a botanist, read an online report that stated that adding coffee grounds to the soil of rose bushes will produce more roses. Holly decides to conduct the experiment to investigate this claim. Okay, so she grows 30 rose bushes in a greenhouse with a controlled environment. And let's see where we have the important information. So the first, we need to find the treatments. So the treatments are specific conditions applied to the individual subjects in the experiment. So here, if you read in the second paragraph, you can see she randomly assigns 15 rose bushes to 1/2 cup of coffee grounds added to their soil weekly, and the other 15 rose bushes with no coffee grounds added to their soil. So treatments are 1/2 cup of coffee grounds added weekly, and the second treatment is no coffee grounds added to the soil. And then we need to find the experimental units. The experimental units are the individual subjects or objects in the experiment. In this case, those are the 30 rose bushes, or a month-old 30 rose bushes. Next, we need to identify the response variable. So the response variable is the outcome variable, or what is it that we are measuring. So if you read, you can see after 3 months, she counts the number of roses on each rose bush. So the response variable is the number of roses on each rose bush after 3 months. In part B, we need to describe how the treatment can be randomly assigned to the experimental units so that each treatment has the same number of units. So there are 30 subjects in the experimental unit and 2 treatments. So we have to assign 15 each to each of the treatment groups. So the first step would be label the rose bushes from 1 to 30. And second, use a random number generator or any other random method to generate 15 unique numbers from 1 to 30 and assign these 15 rose bushes to the treatment group where 1/2 coffee ground is added to the soil weekly. And then the other 15, assign the remaining 15 rose bushes to the control group where no coffee grounds is added. Now part C, after the experiment, Holly determines that her results were statistically significant at alpha equals 0.05 level of significance. Explain the meaning of statistically significant in this context. Now to answer to this question, let's just step back and think. What was the original claim on this report? So the original claim was adding coffee grounds to the soil of rose bushes will produce more roses. So now Molly is conducting an experiment to see if this claim is true. So if she were to do a hypothesis test or a significant test, the null hypothesis, HO, is going to be mu1 minus mu2 is equal to 0. That means there is no difference in the true mean number of roses produced by rose bushes treated with coffee grounds and the ones treated with no coffee grounds. Now the alternate hypothesis is based on the claim. That is, mu1 minus mu2 is greater than 0. That means adding coffee grounds produce more roses than the ones with no coffee grounds. Now the observed result is statistically significant if there is a significant evidence for your alternate hypothesis. That is the p-value, or the probability that an observed result is as large or larger than the observed value is less than 0.05. That is when we reject the HO and we find that there is a significant evidence for HA. So for her result to be statistically significant, the p-value should be less than 0.05. That means it is unlikely that the result might have happened by chance alone. And if we put all that into words, so here we are basically interpreting the p-value. Assuming there is no true difference in mean number of roses between the two groups, that means the group where the coffee grounds were added to the soil and the second group where no coffee grounds were added, Molly's results would be statistically significant at alpha equals 0.05 significance level if the probability of observing a difference in sample means as large or larger than the observed value is less than 0.05. Or in other words, the difference in mean number of roses is unlikely to have occurred by chance alone in this random experiment or in the random assignment.